As we all know, technology innovation is driving down the cost of solar systems and accelerating its deployment. With us today is Ravin Singh, who is the Senior Technical Manager for JA Solar. Ravin will talk us through JA Solar's technology and the solution that it offers to the sector. Ravin, the floor is yours. You may take it from me.
Good afternoon and good day to everyone. I hope you can hear me clearly. So as we wait for my presentation to come up, there we go. So thank you again to Euroconvention to allowing me to speak here at Renpower Nigeria 2021. Today I am from a company called JA Solar, and I'm going to JA Solar as the right partner with the broad base of products for emerging markets and microgrid, microgrids. As mentioned, my name is Ravin Singh. I'm the senior tech. And can we move on to the next slide? I don't know why I don't have control. Here we go. So these will be the contents that I will cover today. It'll be a short introduction into JA Solar, levelized cost of energy, growth, or what's happening in the module market, and technical highlights of one of our products called Deep Blue 3.0. As we move on to the next slide, so this is us in terms of who is JA Solar. JA Solar was founded in 2005. So we've been in the industry quite some time. We've got an annual revenue of about approximately 3 billion. In 2019, it just went over 3 billion. In 2018-2019, we were ranked the second largest global module manufacturer. And in terms of R&D spend, we have one of the largest R&D spends. We spend approximately about 11% on R&D expenses. So that's about 37 million. We also have it's approximately about 10% of the global market share. We have 12 global manufacturing bases spread across the globe. We have around 33 million customers worldwide. We have a annual production capacity that is greater than 15 gigawatts. And we have approximately 22,000 guys on the ground servicing and selling across the globe. In terms of what's happening with the levelized cost of energy, this was a forecast that was done in 2018 by IRENA. And what IRENA predicted or said in 2018 that the levelized cost of energy from PV modules will move down from 37 US dollar cents to about 3 US dollar cents in 2030. Which was a dramatic or a remarkable decline in the cost of PV. However, what has actually happened is, as we can see it on the next slide, which is a study that was done by Lazard, which was released last year October. This shows us clearly that that 0.03 cents levelized cost of energy from PV was actually met in is actually on board 0.4 cents here, and we're on board to meet that actually in 2019. So a forecast that was predicted in to be met in 2030, we are on forecast according to this study, to meet in 2019. And as you would know, there's a few projects that are due to come online in the PV industry in 2022, which is a lot lower than these costings. So what does this actually mean in terms of the levelized cost of energy to us? So if we can move on to the next slide. So yeah, in a PV plant, this is a typical breakdown of cost of a PV plant, and you can see it's generated across, this data is generated across different countries across the world. What is a bit apt to us is South Africa, which is a country that sits on the African continent. And you can see here approximately in blue, 50% of a pure PV plant sits within the PV modules. The cost of a PV plant sits within the PV modules. So that is why JA Solar has decided to spend a lot of money in terms of R&D to reduce the cost of PV modules that come out there. This effectively enabling the cost or the reduction of the cost reduction of PV modules effectively reduces the LCOE costs of energy from any PV plant. Can we move to the next slide? So in terms of a mini grid setup, these are the costs that are spread across a mini grid setup. You can see that the bulk of the cost still sits with PV modules again, with batteries, and your distribution grid that needs to be set up for a mini grid. It's all dependent on size. Your PV modules and your battery cost will always be there. Your distribution grid cost can vary dependent on the size. Therefore, a reduction in the cost of PV modules will allow for a reduction in the LCOE. So this is what JA Solar has been doing to enable this to happen. So from 2009 to 2012, there was not much change in terms of technology on PV modules. You can see it was from 290 watts to about 310 watts. Then came the introduction of multi-bus bar, which allowed it to jump from 320 to approximately about 320. And then came the era of PERC technology, which has pushed module efficiencies a lot higher and allows us to get to 500 watts plus per panel. And I'll take you through these technologies in the coming slides in terms of what's MBB, M6, and M10. So this is what is called half-cut technology. So the half-cut technology comes about by improved laser cutting. It allows lower resistance loss. Lower resistance loss means higher yields. It gives you a lower nominal operating cell temperature, which allows for, again, higher yields. There's better shading behavior in terms of half-cut technology. If one half of the panel is shaded, the rest of the panel still can operate. And there's lower hotspot temperatures, which alleviates micro cracks within the PV panel. So in terms of multi-bus bar technologies, there's a traditional flat ribbon, which is is replaced by a round ribbon. What the flat ribbon used to reflect light. The round ribbon allows to absorb light, which pushes up efficiencies and allows for allows you to achieve much higher efficiencies. In terms of the wafer lengths, traditionally we had 158 millimeter was the standard. This has now been pushed right up until the 210, where JA Solar sits at the moment, and predominantly plays is in the 182 millimeter wafer length market. That this is where we see a lot of our production going into. What we believe is that instead of just increasing the size of panels, we believe in creating more efficiency at this sort of size to give you more wattage per square meter. We're also the first module supplier to apply gallium doped wafers. This allows for less degradation. As you can see, you'll get 2% in your first year and 0.55% moving on. That's for single glass. In terms of double glass, it's also 2% degradation, and moving on year on year after that, it's 0.45%. So why do we say, or why do we ask the question, is a larger module better? We could just be creating larger and larger modules, but that's not necessarily the case. What happens when you create larger modules is you get your risk of damaging your modules, breakages, cracking appearing on site is increased. Therefore, this thing you also have higher mechanical loads because of your higher surface area. It becomes difficult to transport the bigger the modules. And in terms of your racking and mounting, you need higher quality rack bearing abilities on that aspect of it. Therefore, what we are saying is, let's not just keep increasing the size of the panel. Let's look at keeping the size of the panel the same, but increasing efficiencies to give you a lot more wattage per panel. If you can move on to the next slide. So yeah, that brings us to our logic of why we say M10 technology. That's again predominantly where we pouring a lot of our R&D into. This gives us this sort of panel where our value core is to reduce their levelized cost of energy for our customers. This technology is called Deep Blue 3, or this series of panels are called Deep Blue 3.0. Here you can see the open circuit voltage approximately ranges at about 50 volts, and your short circuit current is about 13.8 amps. So again, why 182 millimeters in terms of that? We have a mature supply chain for this. It's existing technology. It's proven technology that's out there. There's less compromises in terms of your string strength, reducing cost of mounting, pile foundations, cabling, your balance of plant, etc. So in terms of the Deep Blue technology, it's already available in 66 cell or 72 cells out there. As mentioned, there's over 14 gigawatts of capacity, this thing that we have available at the moment. Double glass, single glass, it's available there. Your weighting constraints per panel is about 28.5 kgs there. And this is just a product map in terms of the technology, what you would find. In terms of double glass, 60 cells, you'll get from 335 right up to just about 340. In terms of single glass, 60 cells, you'll get from 335 to about 340, 345 there. In terms of the Deep Blue Series 2.0, you double glass, here you'll get 370 to about 385. Single glass, you'll get about 380 to about, 390. And move on to the next slide. Yeah, in terms of the 72 South map, we have, in terms of the 72 cell map here, we have the ranges starting in the double glass just above 400. So you're looking at about 405 in terms of single glass, starting also about 410, going up to about 415. That's on the thing Deep Blue 1 series. On the Deep Blue 2 series, it goes up approximately about 535 to 545 on there. And if we move on again into the next slide, yeah, just to recap everything in terms of that. I mean, we've got IP rights for gallium doped at the moment. What gallium dope does, it allows for less degradation. In that aspects, our whole entire goal is to reduce the levelized cost of energy in all systems, whether it's decentralized, off-grid, grid-tied systems, utility scale, right down throughout throughout the scale. We've actually run some studies, and you can see this little circle here, where in terms of our 535 module, we've done it on one of our reference sites. If we used a 430 watt module versus a 535 module, we've reduced costing there between 7 and 9% in terms of that. And that is me. Thank you. Thanks a lot, Albert.
Thanks a lot to Ravin. For a non-technical person, I'm very quite impressed with the work that your company is doing. We are now moving on to a panel discussion. And for those of you who are joining us, please, if you have any questions, you can type them in the Q&A box, and then we'll refer them to the panelists to answer. But I'll tease off the Q&A session before Kathy has a chance to catch her breath. I'll come to you with my first question, and that is, what do you see as the primary risk or challenges preventing financing of mini grids at a scale in Nigeria? So in the interest of time, please, we encourage you to limit your responses to 1.5 minutes or so everybody would have a chance to take some questions. Thank you.
All right, am I picking that one up, Albert, to kick us off?
Yes, okay. Please.
Yeah, I think that it's there's a number of key risks that we've identified, and we've kind of organized our activities around them, and including just the scale of mini grid operations and the lack of contracted cash flows that have unlocked capital in the utility scale space, particularly because of the ability to de-risk those projects through specific off-taker agreements and the like. And similarly, the inability to pool assets and achieve the ticket sizes of some of these larger capital providers. And then overall, kind of the alignment of the risk profile of mini grid development to capital providers as well. But I do think that, a lot of that is, a lot of the key players in the market are becoming pretty aware of those risks and seeking to identify more innovative solutions for addressing them. I think some of the continuing barriers continue to be the foreign exchange risk. We see that very frequently in our conversations with mini grid developers and investors, as well as some of the areas that a number of the other panelists mentioned in terms of ability to kind of like the timing and structure of the different subsidy programs that are critical for justifying the return for equity or impact investors or the like. Yeah, and then finally, I guess one of the other things that we see a lot is the various collateral requirements for, like, the pretty high collateral requirements for debt financing. which is critical for, again, justifying the return to investors. So quick summary, but I'm curious what the thoughts are of the other panelists as well.
Okay, thank you very much, Kathy. Ron, I'm coming to you. There seems to be an impatience to do more and to do it faster with regards to development in the off-grid market. What do you think can be done to scale the off-grid solar market in Nigeria further?
Yeah, I think you're right. Of course, there is always people want more and more impact and scale the business even further. I think a key there will be, though, in the future is not only to scale very fast, but to also make sure that that scale is actually sustainable for the market, and those companies are either profitable or supported in a different way, which could also be in the beginning, of course, by demand side or supply side subsidies. I think as we are thinking through how to scale the market even further, of course, on the one hand side, you always need more investment. And for an investor, you have the investment drivers, which are the awareness, the insights, and also some new financial vehicles. But on the other hand side, you have the companies where the drivers are more the capacity of those companies, the profitability, the growth, and as well the impact. And thinking through like how to scale the market even further, you have to think through some of those the challenges that I also mentioned in the beginning, as well as some of those business drivers. And I think for me, there's three key areas for Nigeria. One is to enhance the affordability, which is by more mobile money penetration, more pay-as-you-go, potentially also think through whether we could lessen some of the taxes, and otherwise to have more clear guidelines around how how the customs are, and around the import duties. And then the second one is to really enhance the performance of companies, mainly through kind of more customer support, e-waste, circularity, as well as having a really good focus on credit risk management. And lastly, to have more and more data, and especially the data that's lacking at the moment, which has been mentioned a lot, is kind of the financial data available for companies to improve and for investors to have more insights and transparency. And then the last one is more effective coordination and having more dialogue between also the government players and as well as the industry players.
Thank you. I have a question from a participant, Eluma Obibaku. I'm going to direct this question to Jessica, and it goes, can mini grid be profitable without grants or subsidies?
Hi, thanks for the question. I think that right now it's too early to know what the market's going to look like at scale. But I think that, but the answer, the question is sort of taken in a vacuum. Can mini grids be profitable without subsidies? But the larger question is, can the energy market in Africa or the energy market anywhere be profitable without subsidies? And when you look at the European utility market and the American utility market, the level of subsidization that went in to build both the infrastructure and the generation capacity is extremely large. And the idea that we would then ask some of the poorest countries in the world and the poorest consumers in the world to bear the full cost burden of that is disproportionate, and it's not ethical. And so, you know, any one of these companies could be profitable if you could charge whatever you wanted for power. But these are companies that are all constrained by the consumer pricing because they're regulated. And so we have to make a decision as a sector, who bears the cost burden for that electrification? Is it the consumer? Are we comfortable with charging, you know, somebody in rural Nigeria or somebody in rural Somalia or somebody in rural Ethiopia $1 per kilowatt hour? Or should that be a cost that's borne by the government or by donors or some combination? But, you know, if you look at California's utility grid, the government guarantees a return on investment to the California utilities. And if they don't see that, then that's borne by the taxpayers. And when you look at the entire infrastructure for Europe, every distribution line, every connection, every transmission line was built with government money. And we need to start thinking about the African energy market in the way that we've developed the energy systems in developed markets, and that requires subsidization.
Thank you, Eluma. I hope you find this answer satisfactory. In fact, I do, so hopefully it's the same at your end. I'm going to go to Ahmad from REE. So Ahmad, what role can innovation play in the renewable energy space in Nigeria? I see that there are several initiatives that your organization or agency is undertaking. Can you tell us what role innovation can play in that regard?
Okay, thank you very much, Albert. And thank you, Kathy and Jessica, for giving us that insight onto sustainability and, of course, how to ensure that we continue to scale the renewable energy market within the country. I think some of the things you mentioned have been well noted, and there are efforts that we are also making tremendously here in Nigeria. So as Albert mentioned, research and innovation for us is very pivotal to the work that we do. Recently, we launched a Research and Innovation Hub within our REF program, just so that we ensure that for every product that is able to go from start to finish, research and innovation continues to play a very, very critical role in that. So we look to mimic that at the REA, where we ensure that new technologies are being piloted. So for the renewable energy space that we have, we do understand that with solar mini grids, solar home systems, I think we have done quite a lot on that already. However, with areas touching on biomass, small hydros, there's still quite a lot to be done here in Nigeria, even understanding the technology and understanding how to implement that technology. So this is why, we've set up this Research and Innovation Hub, just to see what our younger players have within the space in terms of bringing their ideas, so that we can have some prototypes to see how we can use the REF to support those prototypes. So once we are able to demonstrate that we have some viable cases, we look to now see how we can scale those new technologies even higher. So with this innovation program and research, we are working closely with universities, so we have some professors, we have some younger students actually coming into the REA to carry out research alongside some of our colleagues at the REA. So I think in terms of understanding the role that it plays, I think it continues to play a critical role because it now opens up other sources of energy that we would use for rural electrification that we didn't know before. So I hope that helps answer your question.
Yes, it does. Thank you for that response. Okay, I'm getting feedback. So, okay, it's better now. So we are moving on to a more technical area, and then I'm coming to you, Jay Solar. Understand there's a tag team here. Is Ayowale OJO ready to join in answering questions? If you are, this question goes to you. What are the key challenges faced by solar project developers in Nigeria, and how are Jay's technologies and solutions best suited to the market? So, Ayowale.
Hi, I can hear you, Herbert.
Okay.
Thank you so much. And thanks to all the panelists. It's been a wonderful and informative session thus far. In our presentation, one thing that I may just want to highlight is JA Solar. On the African team, we have different people covering different markets. So we have a South Africa sales manager, we have a SADC sales manager, we have a North Africa sales managers, and I cover West and Central Africa. And beautifully, I work from Lagos, Nigeria. So I am on the ground. I understand the business in its way. On the challenges on ground in Nigeria, yes, a lot of developers will talk about financing. It's like the elephant in the room. Jessica highlighted, a lot of people have highlighted that. Also, the current FX regime is an issue. So not being able to move money out, even if you, we are technology suppliers, but paying for solutions can be a challenge because of the limits of how much you can transfer, the kind of funds you can transfer. You can't just transfer any FX from you have to just get an inflow to transfer. These are the challenges that are being faced. Also, uncertainty on the side of the off-takers. Also, transparency in tendering. These are some of the challenges they face. Custom clearing and port issues. These are challenges that everybody talk about. But as JA Solar team, outside of our technology, we try as much as possible to alleviate these challenges in its way. Talking about shipment, for example, we try to support our partners and ship to any port that you think you can work with. So even to Kano dry ports, we work there, which it makes it faster for you to clear. That's just one challenge. For FX issues, we try to have flexible payment terms for you to be able to move funds and all. And also for technology, which you asked, which is very fundamental. I want to believe that we were the first persons to ship out in the industry. Now we talk about the 540 multi-bus bars. We are like the first persons to ship it out to Africa. We ship it out. That was last year. And in Nigeria already, a couple of developers are beginning to use these solutions that reduce space. So for space reduction, for cost of mounting structure reduction, these are things that is being done, and it's been very wonderful to the developers. So we support largely developers from the ground because we are in the business together back home.
Thank you, Ayowale. So I think the last person who has not answered the question is Warren. Warren, I understand that every element, every item that you add to the balance of system, adds to cost. So you keep on selling the idea of using smart meters. Can you tell us how smart metering systems can help decrease operating costs for mini-grid developers or operators?
So smart metering systems provide data. We provide power quality metrics, we provide consumption usage, we provide losses information, and we can provide it at a relatively good granularity, as I said, like every 30 minutes, every hour, typically. This allows for remote operations of the mini grid. You don't actually need to have boots on the ground year round on site, especially when sites are far away and getting to site is very, very expensive. You want to minimize the number of times that a technician is required to go to site, and you want to be able to manage that site, do load shedding, analyze what you're doing, from afar, and then go to site when you absolutely need to. And when you go to site, know exactly what you've got to do on site and where you've got to go and what kind of problem you're going to face. That allows your technician to get more done in the time that they have in the day. So those kind of things help reduce the sort of service and maintenance operating costs. The other part of it is going to be around data. And as we mentioned, smart meters create a lot of data, getting that data back. So it's making sure that the data is obtained as cheaply as possible, but at the right volume in order to underpin everything else that it provides. And by working with that, and then the third thing, of course, is skills transfer. So we need to increase the help and support we provide and train the trainer, so that they're more, the utility themselves can operate their system effectively. They know how to solve their problems. They don't have to wait to come to us and get an answer and go back, and that they are able to operate very, very efficiently. Those three key areas, service maintenance, data costs, and, self-support are the three areas which really help constrain OpEx. The great thing is that the problem we face is not OpEx and paying for the ongoing service. It's actually paying for the purchase of the system initially. Once the OpEx is up and running, and people are getting what they need, they use more power, it becomes more sustainable. And, our proportion goes from like 16% to 8% of the OPEX cost per month.
Okay, thank you for that. I think I have room for just one more question. And I can only allow 2 minutes or so maximum for an answer. So I'll go to Ahmad. If you can do it in 30 seconds, I'll pass on the remaining time to the others to just chime in. But this is a very topical issue that we are all confronted with. How did the REA react to the COVID-19 pandemic? How did it affect your work? If you make it on time, I can have other people, come in. So Ahmad, please take it over.
Okay, thank you very much. I'll try and abide to the 30 seconds. So as I mentioned in my presentation, from the onset, we quickly tried to see how we could provide power to some very critical infrastructure, especially isolation and treatment centers. And that has now given birth to 2 separate programs. One program to to provide power for 100 isolation and treatment centers nationwide, then 400 PHCs nationwide, that's with the World Bank. And as part of the federal government, we are going to provide additional 200 mini-grids to PHCs. And in addition to that, and I think it was either Kathy or Jessica that made reference to this, we were looking at how those mini-grids within the primary healthcare centers can continue to serve as anchor loads to also grow our mini-grid network. So I don't know if that is within time. Also, of course, the Solar Power Niger program, which I think has been discussed extensively today.
Well, I take it that you answered on behalf of all your colleague panelists, so I'm not going to allow for more time for anybody to chime in. Let me take this opportunity to thank you all for making time to be with us this afternoon.